All right, guys, so welcome to the notes on all 6 trig functions. So up until now, we've only had our 3 trig functions, but there are actually 6 trig functions. I'm trying to find a different highlighter, but I can't find one, so oh well. Okay. All right, so all 6 trig functions. So up until now, again, we've had our 3 trig functions. Our 3 trig functions are sine, cosine, and tangent, and they're giving them to us off to the side. So let's go ahead and fill in the missing one here. So we've got sine, cosine, and tangent of theta, right? Sine, cosine, tangent. And so this little saying, SOHCAHTOA, right, it helps us to remember those 6 trig functions. So what we know is that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And we have 3 more functions. So they are cosecant theta, secant theta, and cotangent theta. Now what you noticed is I wrote them in a specific order. It wasn't a fluke that I wrote them in that order. I wrote them in that order because sine and cosecant, they are related to one another. Cosine and secant, they're related to each other. And tangent and cotangent are related to one another. And so I'm going to show you what that relationship is. Like, how do you know that they're, what the relationship is? So what we know is that sine theta, cosine theta, and tangent theta in a right triangle, sine represents opposite over hypotenuse, cosine represents adjacent over hypotenuse, and tangent represents opposite over adjacent. And so what does that mean about secant, cosecant, and cotangent? So cosecant theta is the reciprocal of sine. So it would be the hypotenuse over the opposite. And secant theta is the reciprocal of cosine. So it would be hypotenuse over adjacent. And tangent theta and cotangent theta are reciprocals, and so this would be adjacent over opposite. All right, so something that helps me remember, well, first of all, tangent and cotangent, they have the same word, tangent. So that one, I never confuse those two. Now, how do I not confuse these? So sine and cosecant, you have an S and a C. And the same thing here, secant and cosine, you have an S and a C. So always SC and SC. All right, so now that we know that, we're going to go back and review one of the topics that we did last week. So part 1, angles not on the unit circle. And I'm actually going to put on the unit circle. So when you have an angle that's not on the unit circle, you can tell because, number 1, the angle that they, or the reference that they give you does not necessarily make a ratio that you've seen, or number 2, they've given it to you as an ordered pair or in a form like this. So let's go ahead and talk about angles that are not on the unit circle. All right, this angle could be on the unit circle, but I don't know for sure because they didn't tell me how much theta was. So we're going to go ahead and sketch the reference triangle. So the first thing that we do is we go through the point to the point -2, 1. So on the xy axis, we're going to draw our xy axis. Right, -2, 1 is right there. -2, 1. All right, so we're going to go ahead and draw in our reference triangle. So remember, our reference triangle, we draw always back we refer to our mother axis, or x-axis. There's my right angle, here's my ray, and here's my base. And so the length of this side is 2, but don't forget it's going to be a -2, so I'm just going to go ahead and put my negative on there. Even though we're just talking about length, I want the negative on there so I don't forget. And then this will be 1, because we always need to watch our signs. Okay. So by putting the negative, I should not make an error. But if you would rather not put the negative, you could just remember that little saying I said about the unit circle. All students take calculus. And so in this quadrant, sine will be positive, and cosine and tangent will be negative. All right, the first thing we need to do is find this missing side length. And so to do that, that is the hypotenuse, right? It's across from the right angle. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So a squared plus b squared equals c squared. Now you notice I'm using positive 2 because I'm going to square a negative and it'll become positive anyway. So that would be 1 plus 4, which is 5, equals c squared. And then I'll square root both sides, and c equals the square root of 5. So square root 5 goes right there on your reference triangle. All right, we're going to find sine theta, cosine theta, and tangent theta. All right, so sine theta, sine is from this angle, right? That's my angle theta. Sine is opposite over hypotenuse, which is 1 over root 5. Now, normally we rationalize, but I'm going to leave these unrationalized. But if you're doing IXL, you need to rationalize. Cosine theta, cosine is adjacent over hypotenuse, which is -2 over the square root of 5. And tangent is opposite over adjacent. So opposite over adjacent, which would be -1 over 2. Right, one of these has to be negative. I prefer to put the negative out front or in the numerator. All right, so it's super easy now to find cosecant, secant, and cotangent, because they're just the reciprocal of sine, cosine, and tangent. And so the reciprocal of root 5 over 1 is, 1 over root 5 is root 5 over 1. You don't have to put the over 1, but I'll show it just so that you can see that it's the reciprocal. And the reciprocal of cosine would be negative square root 5 over 2. And the reciprocal of tangent would be negative 2 over 1. And there we go. All right, number 2. This time we know that the angle, it says find the exact values of the 6 trig functions given that cosine theta is -2 over root 3. So this is a little different. They're not giving us a point. They're actually giving us the ratio. And we're in quadrant 3. So we're going to start in the same way. We're going to draw our x and y axis. Since I'm in quadrant 3, I'm going to focus on that quadrant. And I'm going to go ahead and draw a right triangle in. It's going to be down here in quadrant 3. And again, this is a sketch because I don't know exactly how big this side is, or this side is, or this side. I just know that, well, actually one of them I do. I know this one's -2. So this is -2. Now, how do I know that? Well, here's my angle theta, right? Here's theta. And so it says cosine is -2 over root 13. That means that this is my adjacent and this is my hypotenuse. So adjacent to hypotenuse. That tells me that if my angle is right here, which I'm always referring back up to the x-axis, then this would be adjacent, which would be -2. If they had given me sine, that -2 would have gone over here, because it would have been opposite the angle. And then the hypotenuse is square root 13. So we're missing this value. We're going to again use the Pythagorean theorem, but be careful this time, right? Our hypotenuse is given, so our c squared is given. So our setup will be a little different. So that would be 2 squared. And I know it's negative, but I'll square it anyway, so it doesn't matter. Plus, I don't know it, so I'll call it b squared equals c squared, which is square root 13 squared. And then we should know that a square and a square root are inverses, so they'll reduce. So it would be 4 plus b squared equals 13. Subtract the 4 over, b squared equals 9, and b equals plus or minus 3. So I do know that since I'm in this quadrant, it will be negative 3. All right, now that we have all three sides of the triangle, we're going to go ahead and write our three trig functions: sine, cosine, and tangent. And after we write those, then we will be able to say, okay, then we'll know cosecant, secant, and cotangent. All right, and then if you can always use these negatives, but if you've forgotten, it's all students take calculus. That tells me that tangent will be positive in this quadrant. All right, so sine. Sine would be opposite over hypotenuse, which would be negative 3 over square root 13. And that tells me that cosecant will be the reciprocal of this, which would be negative square root 13 over 3. All right, next one would be cosine. Cosine is adjacent to hypotenuse, right? They already gave it to us, though. That was negative 2 over square root 13. And so secant would be the reciprocal, which would be negative square root 13 over 2. And finally, tangent. Tangent would be opposite over adjacent. And so you can see why this will be positive. Negative 3 over negative 2 would be positive 3 over 2. And then cotangent will be the reciprocal, which would be 2 over 3. All right, so that was for part 1, angles that are not on the unit circle. Now, angles that are on the unit circle. So angles that are on the unit circle. Now, how do we know that they're on the unit circle? So it says find the exact values for the 6 trig functions of theta. And it says that our angle, right, is pi over 2. Well, this time we're given the angle, and so we can tell whether or not that's on the unit circle. I actually could tell that this one was on was not on the unit circle because my hypotenuse was a square root 5. So that's impossible, right? A square root 5, the hypotenuse should be a 1 if we're on the unit circle. And I could tell the same thing here, that this was not on the unit circle because we had square root 13. And our, again, our hypotenuse, which is the radius, should be 1. But this one, they've given me this angle pi over 2, and pi over 2 is on the unit circle. All right, so pi over 2, it's actually negative pi over 2, excuse me. So I'm going to go over here. I'm actually going to grab my completed unit circle. Why would I recomplete this right off to the side when I know I can use my unit circle? So let me grab that. Of course, I can't find it. Of course, I still can't find it. There it is. Thank you. All right. So my unit circle, negative pi over 2. The only thing I am going to sketch, negative pi over 2, that means I'm going backward pi over 2. Right, so backward pi over 2, I'm going to end up right there. So let's look at that on our unit circle. Our values of x and y are 0 and negative 1. And so here, right, my values of x, comma, y were 0, comma, negative 1. All right, so now my functions for sine, cosine, and tangent. Oh, here they went ahead and they reminded us that sine is not just opposite over adjacent, but it's sine over cosine. And let me explain for just a second why that's true. So on the unit circle, remember, where's my paper? Here it is. Okay, on the unit circle, you recall that that the radius r, right, is always 1, And then this is our x value, and then this would be my y value. And so sine of theta ends up being opposite over hypotenuse, which is 1, or just y, and then, or just opposite. Because our hypotenuse is 1. Cosine theta is our x value adjacent, which is x over 1, or adjacent, and over 1. And opposite over adjacent is tangent. So tangent theta is opposite over adjacent, or y over x. Big idea here, guys. So make sure that you put that down. Not only is it sine over cosine, it's also tangent theta is y over x. So we had talked about that a little bit last time. All right. So I'm going to actually star this guy and this guy. All right. So sine, cosine, tangent. There's not a ton of room here, so I'm going to try to fill it in as small as I can. Sine theta, cosine theta, tangent theta. So sine is y, y is -1. Cosine is x, x is 0. And tangent is y over x, which is -1 over 0, and that would be undefined. You cannot have a 0 in the denominator. All right, so now for cosecant, secant, and cotangent, I think I'll come over here. So this is number 3. It's cosecant theta, secant theta, and cotangent theta. It's just the reciprocal. Well, the reciprocal of -1 over 1 is -1. The reciprocal of 0 over 1 is 1 over 0, which again is undefined. And the reciprocal of -1 over 0 is 0 over -1, which is 0. And those would be our 6 functions. So sine and cosecant end up being equal. Cosine and secant go from being 0 to being undefined. And tangent and cotangent go from being undefined to 0. And so hopefully you can kind of see that relationship, that if you have one of them being 0, if you take the reciprocal, the other one will be undefined. All right, 540 degrees. So 540 degrees isn't directly on our unit circle, if you notice. Our unit circle goes to 360. However, if I were to use the idea that there are coterminal angles, I could take my 540 degrees. So I would take my 540, I would subtract 360 from it, which would give me, I believe it's 180, but I'm just checking. 540 minus 360 is 180. So this is the same thing as 180 degrees on the unit circle. And so if we go over to our unit circle and we go to 180 degrees, our values are -1 and 0. So this time x comma y is -1, 0. Let's go ahead and write all 6 trig functions. So we've got sine, cosine, and tangent. And then we're going to have cosecant, secant, and cotangent. All right. Again, sine, remember, is our y value, so that would be 0. Cosine is our x value, that would be -1. And then tangent is y over x. Y over x would be 0 over -1, which is 0. Now remember that relationship that when we have a 0, its reciprocal will be undefined. So this value will be undefined, and this value will be undefined. Again, if we take the reciprocal of 0 over -1, we'll have -1 over 0, which is undefined. This guy, if I take the reciprocal of cosine, it will still be -1. All right, working backwards. It says, what if, it says 0 is less than or equal to theta is less than 2 pi. All right, so they're telling you that the angle is from 0 degrees to 2 pi degrees. So we're not going to go past 360 degrees. Okay. Determine the values of theta for which sine theta equals -1/2. All right, so sine theta, just to remind you, right, sine is your y value. So where is y equal to -1/2 on your unit circle? So let's go ahead and look back at the unit circle. And we want to know, where is y -1/2? Well, y is +1/2 here, so that's not correct. It's not 1/2 here or here, or here, or here, or here. Sine is negative right here, -1/2. So that would be at 210 or 7 pi over 6. Since they're using pi, I'm going to use 7 pi over 6. And there will be a second value. There's almost always a second value. On this one, if I go to -1/2 right here, it would also be at 330 degrees or 11 pi over 6. All right, let's go ahead and flip this guy over. So reference triangles for theta. Reference triangles. It says always with reference to the x-axis. So make sure that you fill that in, to the x-axis. And you notice that this person thinks this is super important because they have literally put 3 exclamation points. And you should be thinking, how far back to x? To the x-axis. And that is your theta, right? How far back? So it says find the reference angle of theta. Give answer back in same measure given. So what that means is if we're in degrees, we're going to write our answer in degrees. And if we're in radians, which is pi, we're going to write our answer in radians. So 30 degrees. How far back to the x-axis? So if I were to draw an angle that's a 30-degree angle, I would start with my ray on the x-axis, and then my 30-degree angle, I'd put it right here. There's my terminal side, and I would drop my triangle straight down, and my radius would be a 1. And this angle would be 30 degrees. That is my reference angle. So if I want to use that on my unit circle, I would refer to a 30, 60, 90 triangle. All right, the next one, 140 degrees. So I'm going to, again, start on the x-axis and draw my initial. But then my 140, I would go 140 degrees, which would be, there's 90. I would be 50 degrees past. And so this angle would be 140 degrees. But when I draw a reference triangle, I always refer to the x-axis. So I would drop down to the x-axis, and I would be using this angle right here. And so if this is 140, then this angle to get to 180 degrees, the distance from 180 to 140 would be 40 degrees. All right, the next one, 200. So 200 degrees, I'm going to start here on the initial ray, which is my x-axis, and I'll move 200 degrees. So 200 degrees, this is 180, so I would go past 180 by 20 degrees. And so this entire angle would be 200 degrees. But when I draw my reference triangle, I refer back to the x-axis to draw my reference triangle. And if this is 180 degrees and I've gone 200 total, then this angle must be 20 degrees. And so my reference angle would be a 20-degree angle. All right, now 5 pi over 6. If you don't like using pi, if you like using degrees better, you can. To do that, though, you would have to convert this into degrees by multiplying by 180 over pi. Right, your pi's would reduce. 6 would go into itself once and in there 30 times, and then this would be 150 degrees. And you could draw that instead. A lot of students prefer to do that. However, I'm going to go ahead and work with pi. So what I know is that this is 0 pi, and this is 1 pi. This is 1/2 pi, and this is 1.5 pi, or 3 pi over 2. And then this is 2 pi again. All right, so 5 pi over 6 would be, if I count by 6, this would be 1/6, 2/6, 3/6, 4/6, 5/6 right here. 5 pi over 6 would be right there. So this would be 5 pi over 6. Now, when I draw my reference triangle, again, I'm going to refer back to the x-axis, and I would be at pi. And so if I take pi over 1 and I subtract 5 pi over 6 and get a common denominator, I would have 6 pi over 6. So 6 pi over 6 minus 5 pi over 6 would be 1 pi over 6, or pi over 6. And what you could have done is, if you used this, right, 150, if you went 150 degrees, how many degrees more would you need to get to 180? You would have gotten 30 degrees more, would get you to 180. And if you notice, 30 and pi over 6, 30 and pi over 6, they are the same thing. All right, again, I'm going to do both of these. Actually, since I would be going past, since I would have a 12 in the denominator this time, I would definitely use this method instead. So what I would do personally, actually, I know what this is. Like, I can see that this is 13 pi over 12, which is, if I go 12 pi over 12, that would be 1 pi, right? So I would be just a little past pi, which I'd be 1/12 past pi. But I'm going to do it the other way, a method that doesn't work with fractions. So let's go ahead and change this into degrees. So I'm going to multiply by 180 over pi, and my pi's reduce. And then 12 does 12 go into 180? Let's see, 180 divided by 12 is 15. So 12 goes into itself once and into 180 15 times. And then multiply my numerators. So 13 times 15 is 195 degrees. So this is 195 degrees. This is probably the easiest way for students. I mean, I can see that 12 pi over 12 is 1 pi. So I actually know it's 13 pi over 12 minus 12 pi over 12, which is pi over 12. However, most students won't see that. And I saw that you guys were struggling with fractions, so that probably would be a little bit more difficult. But if you can do it this way, that's fine. All right, so if I go 195 degrees, I would go all the way past 180. to right there. So this would be 195 degrees. But remember, when I draw my reference triangle, I'm going to refer back to the x-axis. How many degrees past, this is 180, right? I would be 15 degrees. 195 minus 180 is 15 degrees. Now, because it gave it to me in pi, I would need to convert it back into radians. So I'm going to convert back into radians by taking this and multiplying by pi over 180. And remember, we already divided this. 15 goes into itself once, and 15 goes into 180 12 times. And so this would be pi over 12. It's amazing, the same answer. All right, negative 100 degrees. So moving backwards 100 degrees, if I'm at 360 and I move backward 100 degrees, I would be at positive 260, right, which would be about right here. Here's 90 degrees backwards, here's negative 100. So this would be negative 100 degrees, or that would be the same thing as positive 260. All right, when I draw in my reference triangle, remember I always go back to the x-axis. So here's my angle theta, and if this is on 180 degrees and I am at 260, how many degrees past 180 am I? So 260 minus 180 is 80 degrees. All right, let's see, last page I believe is homework, so let's take a look at that. All right, so the first one, it says the terminal side of an angle in standard position. So this, to me, right, they give me the 2 points. This is like example 1. Right, warm up number 1. So this is from part 1, number 1. All right, cosine of theta is 2 pi, or is 2 over 3. So this, guys, is like part 1, number 2. All right, it says if sine theta equals negative 0.7, evaluate cosecant. So this, all we need to know is that we're going to look at the relationship between sine theta and cosecant. What's cosecant theta? And they are reciprocals. So you're going to take the reciprocal. If cosine theta and cotangent theta have the same sign, which quadrants can theta lie in? So you're going to go back to the fact that this is cosine is positive in certain places, and cotangent is positive wherever tangent's positive. And on your unit circle, tell me what quadrant or quadrants that happens. All right, the next one, these are like, this one is like part 1, number 2, right? You can put a 1 right there so that you can see. Same thing here, part 1, number 2, put a 1 in the denominator if you need to. All right, and then these, number 7 is, there's 2 of them, right? Number 7 is using the reference triangles, right? So this is coming from reference angles notes. One of them is like number 1 through 3. And this one is like number 4 and 5. And the last one, determine the 6 trig functions. So these are like, they're all, well, this one's on the unit circle and this one's on the unit circle. This one's on the unit circle, and 10 pi over 3 is also, is not on the unit circle. All right, so all 3 of these are on the unit circle. So this is like part 2. Number 3 and number 4. Only this one will, you have to find the reference angle for this. So you're going to combine number 7, right, what you're doing on number